Section 3.2, Changes in Matter. Some objectives are define physical change and list several common physical changes. Define chemical change and list several indications that a chemical change has taken place. Apply the law of conservation of mass to chemical reactions. Some vocabulary review will be observation. And some new vocabulary will come across as physical change, phase change, chemical change, law of conservation of mass. A substance often undergoes changes that result in a dramatically different appearance, yet leave the composition of the substance unchanged. An example is the crumbling of aluminum foil. When the foil goes from a smooth, flat, mirror-like sheet to a round, compact ball, the actual composition of the foil is unchanged. It is still aluminum. A change as this, which alters a substance without changing its composition, is known as a physical change. Cutting a sheet of paper and breaking crystal are other examples of a physical change in matter. As with other physical properties, the state of matter depends on the temperature and pressure of the surroundings. As temperature and pressure change, most substances undergo a change from one state or phase to another. A phase change is a transition of matter from one state to another. This is the case with the water cycle, which allows life to exist on Earth. At atmospheric pressure and at temperature below 0 degrees Celsius, water is in its solid state, which is known as ice. As heat is added to the ice, it melts and becomes liquid water. This change of state is a physical change because even though ice and water have different appearances, they have the same composition. If the temperature of water increases to 100 degrees Celsius, the water begins to boil and liquid water is converted to steam. Melting and formation of a gas are both physical changes and phase changes. Condensation and solidification are two common phase changes of water. Terms such as boil, freeze, condense, vaporize, or melt in chemistry generally refer to a phase change in matter. The temperature and pressure at which a substance undergoes a phase change are important physical properties. These properties are called the melting and boiling points of the substance. Like density, the melting and boiling points are intensive physical properties that can be used to identify unknown substances. Tables of intensive properties, such as those given at the end of the textbook or in the CRC Handbook of Chemistry and Physics, are useful tools in identifying unknown substances from experimental data. A process that involves one or more substances changing into new substances is called a chemical change, commonly referred to as a chemical reaction. The new substance formed in the reaction have different compositions and different properties from the substances present before the reaction occurred. For example, the formation of rust when iron reacts with oxygen in the air is a chemical change. Rust shown is a chemical combination of iron and oxygen. In chemical reactions, the starting substance are called reactants, and the new substances that are formed are called products. Terms such as decompose, explode, rust, oxidize, corrode, tarnish, ferment, burn, or rot generally refer to chemical reactions. Rust is not attracted to a magnet, whereas iron is. The observation that the product, rust, has different properties than the reactants, right, iron and oxygen, is evidence that a chemical reaction has taken place. A chemical reaction always produces a change in properties. Spoiled foods such as rotten fruit and bread is another example of chemical reactions. The properties of spoiled fruit, like its taste and its digestibility, differ from fresh food. It was only in the late 18th century that scientists began to use quantitative tools to study and monitor chemical changes. The analytical balance, which is capable of measuring small changes in mass, was developed at that time. By carefully measuring mass before and after many chemical reactions, it was observed that although chemical changes occurred, the total mass involved in the reaction remained constant. Assuming that this was true for all reactions, chemists summarized this observation into a scientific law. The law of conservation of mass states that the mass is neither created nor destroyed during a chemical reaction. Other than that, it is conserved. In other words, the mass of the reactants equals the mass of the products. The equation form of the law of conservation of mass is as follows, right? That the sum of the mass of the products, the reactants, is equal to the sum of the masses of your products. Let's look at an example. In an experiment, 100 grams of red mercury 2 oxide powder is placed in an open flask and heated until it is converted to liquid mercury and oxygen gas. The liquid mercury has a mass of 9.26 grams. What is the mass of the oxygen formed? You are given the mass of a reactant and the mass of one of the products in a chemical reaction. According to the law of mass conservation, the total mass of the products must equal the total mass of the reactants. Because we know the mass of the mercury 2 oxide and we know the mass of the mercury product, right, but we don't know the mass of the oxygen. And if we know that the mass of the reactants must equal the mass of the products, we know that the mass of the mercury 2 oxide must equal the mass of the mercury plus that of the oxygen. Go ahead and find the difference between the mercury 2 oxide and the mercury, and you'll find out that oxygen has a mass of 0.74 grams. French scientist Lavoisier was one of the first to use analytical balance to monitor chemical reactions. He studied the thermal decomposition of mercury 2 oxide, known then as calx of mercury. Mercury 2 oxide is a powdery red solid. When it is heated, the red solid reacts to form silvery liquid mercury and odorless oxygen gas. The color change and the production of gas are indicators of a chemical reaction. When the reaction occurs in a closed container, the oxygen gas cannot escape, and the mass before and after the reaction can be measured. The masses will be the same. The law of conservation of mass is one of the most fundamental concepts of chemistry. Section summary. A physical change alters the physical properties of a substance without changing its composition. A chemical change, also known as a chemical reaction, involves a change in a substance's composition. In a chemical reaction, reactants form products. The law of conservation of mass states that mass is neither created nor destroyed during a chemical reaction. It is conserved.